Okay, so what we want to do now is create some vectors, views that are going to come basically from the center of the building, looking 360 degrees around, and then determining if they intersect or not to determine whether a view is available through the building. If it doesn't intersect with something, it means you have a clear path through to the next building, so to speak. So we're using that as a basis of determining whether it's a good view or not. So let's do a little bit of housekeeping here. I want to make sure that it becomes legible to read later on. And so what I wanted to do here is I'm going to group all of these. And so I grab them all and I'm going to right click and create a group. And I'll double click on this and I'll call this build floors. And if you look at what's in here, it's determining how many floors there are. And then translating each one of those floors, that distance of a 12 foot high floor that we're separating by 15 feet. So we get this little visual kind of showing us our notching here. So anyway, I wanted to do that, so it brings us up to another point of doing these, what I'm going to call view vectors. And what we're going to do to start off with is we're going to find the centroids, a center point for each one of these. So each floor will have a centroid, and then we can that's a single point, and then we can pull a vector off of it. So I'm going to just do solid dot centroid, and there's all kinds of ways we could do this. This is just a convenient way of finding a single point in an object. If it was a circle, we'd have it in the center also. Alright, so I'm going to plug that in, and we'll run that. And we should get a little dot, and let's see if we have a point. We have 4 points here, and one of the ways we're going to need to actually be able to see that is to kind of hide our geometry here for a moment. So let's go to this and turn the preview off, and now I can kind of zoom in here, excuse me, and you can see our 4 points that are here. And if I click on this, they'll highlight. But they're buried in that kind of geometry. So I'm going to leave this geometry off for a minute. Imagine now these are the center of each one of the floors. You know, that would be a 12-foot floor, so it's at the 6-foot level, right in the center of the building, and then looking out from that building to kind of see whether that sight line hits something else. So, and we have 4 floors now, so we have 4 points. If we go over here and change obviously the width of the building, it's going to get taller, and if we rerun it, we get more points. And you notice how it also jumped closer to the corner of the lot. So we have these points, and we want to build vectors off of them. So we're going to make a line that has a start point and a direction and a length. So let's see if we can actually find that. A geometry, it'll be a curve, it'll be a line that has a start point, a direction, and a length. So the length will be anything that's past where the buildings are. The direction will be one of 360 degrees around or something like that. And the starting point is the centroid point. So I'm going to select that. And we can pull our start point in. Now for our direction we need a vector. If we roll over this, it'll probably say it asks for a vector. And so we need to just come up with a vector and then move it around. So let's go ahead and do that. So I'm going to see if I can find a vector here. Let's see if we can find can't think of where our vectors would be in this. I'm sorry, I'm taking a little bit of time here. Geometry, it should be an abstract piece of geometry, right? A vector. Alright, so we have a vector, and we want to make it a vector rotate. So let's see if we can find that. Vector rotate, and we want to do that by a axis and a degrees. So I've selected that. So now we have this idea of a vector. And we need a vector direction and an axis for that to rotate around. So we want the z-axis. So let me see if I can do a shortcut to that. There's vector z-axis. That's the straight up. So I'm going to tie that into here. We want the y-axis. We'll tie that into there. And then we want to have some kind of degree. We want to do it through a whole series of directions, so to speak. So let me actually just plug this in right away and run this just to see what will show up to begin with. And nothing is showing up because, well, we have a list of 7, but it's really short lines. Let's first of all give it a length. So I'm going to use a code block to give it a length. This will help us visualize it. And let's say I'm going to pick a number here. Pick 1,000. And that would be like 1,000 feet. We'll plug that into the length. And we'll go ahead and run this. And there you can see those are those vectors. It was 1, it wasn't showing up before. Now it's 1,000 feet long. So they're very long lines coming off of each one of those points. But it's only in one direction. And we really want it to be in 360. So we got to feed into this vector rotate a series of angles for that vector to rotate around. So we'll build that series using a code block. And in this case, we'll start at the beginning, 0 degrees, and we'll go to 350. We won't go to 360 because that's exactly back to 0 again. And we'll do it in some kind of a rational amount of increments. So let's do it in 10-degree increments. So we'll put 10 in. And I'll plug that in. And we'll go ahead and run that. And we get only 1 angle per each one of the points. And that's because we're not using the cross product of our tool here. So we're going to go to lacing, and we want to select cross product. And we'll go ahead and run that, and now we get each one of those. And I want to just step back and show you here. We get 36 degrees feeding into here, but this direction and start point is only taking one of those values, and we really want the cross product, so we want to take the multiple angles of that. So now we have, just to step back here so you can see what we've got. We've got all of these vectors. They're lines coming off of our center point of our floors. If at any point we change the number of floors, we go back over here, and let's say we make the building wider, it'll have less floors to it, and run it, we'll only get a few vectors. And if we make it to our lowest value that we've established, which is 40, we'll get the most amount of vectors. And we don't want to show all of this data, but if you zoom in here, right, we can see that we have some vectors that are intersecting with the building and some vectors that are not. And we'll pick up in the next clip the kind of math that we want to do to figure out if something's making an intersection or not.